This is just paper, and here is a magnifying glass. What will happen if I take it over here? No, it won't burn. It's a book, definitely. It's a very important book. I think you can observe an image. This is the image of my window. That greenery, what is looking like a greenery, is actually a tree. And the tree is looking upward, which is actually downward. This is exactly happens inside your eyes and in the retina. This is a prism. What will happen if I pass the light through the prism? Yes, it might get split. And here you can see our favorite rainbow. So the light is getting separated into different colors.
Wow, that's awesome. But, sir, is this how a rainbow forms?
Rainbow doesn't form exactly like this, but yes, it has similar phenomena, mainly the dispersion. Now, what is dispersion? The splitting of light into different colors is dispersion. So let's see how does a rainbow forms. Instead of this, I need to have a water droplet. The major difference between this and a rainbow formation is in rainbow, let's say if this is sun and light rays are going forward, the light won't go far from the clouds and then form rainbow this direction. No, it doesn't happen like this. Like rainbow forms over here and we see the rainbow from here. So let's try to make it and try to see how does it happen. This is our laser over here. This is obviously, it will represent a water droplet, and let's see what happens. So here, now what pattern you found? This pattern. This is the pattern similar to the rainbow, and this is what happened. So here dispersion is there. This is obviously dispersion. But here there is one more phenomena. Can you guess it is? It's total internal reflection. It's not good getting outside. It is getting reflected inside. So here, this due to these two phenomena, total, it is also asked in exam many times that what is total internal reflection. So when light bends so much due to steep angle that it doesn't go to the other medium but reflects back to the same medium, it's called total internal reflection. Not just that, currently the mobile you are using and the geo fiber you have, inside the fiber how internet travels, it's due to also the light. Geo fiber technician, if he cuts the cable and observes it, you can find actually it's glowing by light. Wow! I will try to make a diagram. Like let's say this is that geo fiber cable, this is light traveling. So due to the different density inside the cable, it will not go outward but it will get reflected inward, and then this light passes the signal. Since light is the fastest thing in the world, maybe in the universe, it transfers the internet very fast. That's why it is called optical fiber. And yes, questions are asked on based on this topic, that what is total internal reflection. They might give a case based question in which they might say the same question, how does it helps into transportation of information, or how does optical fiber work, something like that they can ask, and it's really very interesting. We should understand some terms: incident ray, refracted ray, normal, angle of incidence, all those things. Let's say here is this my light source, laser, water. One more thing, there is a thing called optical density. Optical density means the power to bend the light. It bends it towards the normal. Now what is normal? This perpendicular line, this is called normal. It will be perpendicular 90° to the surface. As simple as that. And let me switch on the laser and try to observe. See, did you observe? The light ray is not going straight. It should actually go straight, here to here like this, straight. But no, it's not going straight. It's like bent. At an angle, it's bending. What angle is this? Angle of refraction, not reflection. Reflection means from the mirror. Refraction, R is there, refraction. And here is I, angle of incidence. It's very important for the Snell's law, for the calculations. Snell's law, what is Snell's law? Snell's law is refractive index of a material is sin I by sign R. This medium is air. Now you should understand there is a small difference between density and optical density. Density generally refers to weight also, it is referred to its weight also. Whereas optical density means the power to bend the light. So generally the denser material has more optical density, but that's not the case always. Sometimes glass of the same weight could have more optical density, means it could bend the light even more than the other type of glass. So yes, keep in mind it's not always the same. Now let's see what happens when I take the glass slab towards the laser. Hey, what is this? Again we can see total internal reflection. Let's increase the density a little more. Here you can clearly observe that the light should go straight here to here, the light should go like this, but it's going from here to here different. So therefore we can clearly see it's bending, and this is happen. Now what are the other differences in the rare medium? Here light will be faster, bend far from normal or away from the normal. That earlier a perpendicular line I said, that's normal. For example, over here, this is that normal, whereas here it's bending towards the normal. See the gap, how small is the gap. And here in this optical denser medium, light will be slower, so slow velocity or slow speed. And second, it bends towards the normal. Whichever part you like or it's very interesting or easy to understand, you can take a screenshot, because it helps a lot. When you revise, it will save your time and it will be more easy to understand and revise faster.
Sir, my friend told me that when light bends in water, it's actually breaking the laws of physics. But then, how do fish see us?
Okay, it's very simple. Let's say this is water, and let's say there's a fish. If our position are there, observe, fish can see, but fish will see us at a different angle. But it doesn't affect the fish more because it is already naturally evolved for it. And also one more, we are out of the water, not the fish. So for fish there is only one uniform medium, that's water, and that's why inside the water it's very easy for the fish to see any object.
Sir, my older brother said that diamonds are just carbon. So, why do they sparkle more than glass?
Hmm, that's a very good question. For that we need to return back to our light bending experiment. So let's see. Let's take our lens back and let's switch on our laser. You can see the light ray is forming a rainbow like structure. Now what will happen if I take another glass slab and make it pass from over there? Let's change the angle to have a better observation. And if we have another, let's say, let's have a prism. Wow, it's nice. Are you observing? The more I am changing the angle, the more beautiful shapes it's taking. Now, the thing about the diamond is, it is cut, first of all, diamond has very high optical density. Now, water's optical density is 1.3 and that of a glass is 1.5. But diamond's optical density is 2.4, as high as 2.4. Like adding this one glass, then another glass optical density, and then putting them at a different angle. See, the more I'm changing the angle, the better and beautiful shape it's taking. And that's the reason diamonds are cut at a particular angle, and also they show the phenomena of total internal reflection. That's why total internal reflection, dispersion of light, all these things take place. See, this another prism. How nice and beautiful patterns it's forming.
Wow!
So diamond cannot keep the light forever, but it slows it down and then turns it back and forth. It reflects back the light at in different colors and different angles. That's why it looks like sparkling with colors. So refractive index is sin I by sin R. Now what it tells? It tells the power of reflection or optical density of something. The more denser something will be, the more will be the value. For example, let's say this I is 45 degree, whereas this R is 30 degree. So sin 30. What is sin 45? 1 by root 2. And what is sin 30? It's 1 by 2. Okay, it will cancel out. This thing can be written as 2 by root 2, and this 2 by root 2 can be written as root 2 into root 2 by root 2. Root 2 will get cancelled. We will have root 2, that is approximately equal to 1 by 4. So its value is actually approximately equal to 1.4. And since it's 1.4, means it's bigger than 1, and that's why the water, the example water, not the real water has 1.3 refractive index, whereas this water have 1.4 in the example one. So this is how the refractive index works. What else the refractive index tell? There is another formula for refractive index. Refractive index equal to C by V, or speed of light in vacuum by medium, speed in medium. That's the refractive index. So here are values of some of the important refractive indices.
Yes, sir!
By the way, friends, if you forget to subscribe Best Classes channel, then you can search on YouTube at best.pandeysir. Till the next time, Bharat Mata Ki Jai and best of study. And don't forget the famous phrase of Pandeysir: push past your limits.